Good afternoon, good evening, good morning. Thanks everyone for joining. My name is Michael Cooper. I am here representing Confluent, and I'll kind of be emceeing between two of our amazing experts. We have Dan, who you hopefully just listened to in our in our session just a couple minutes ago on how to do Kafka on Azure with Confluent. If you didn't, the session was recorded. Please do so. Also, one of our experts today is Alicia. Alicia will be focuses in on integration with key data services with Microsoft. And so between the two, we're pretty sure we can answer most any question you might ask or have. The first thing I'm wanted to do before we get into some of the questions and some of the conversations is just to reiterate. Confluent Cloud is natively integrated into Azure now. This is a joint project that Microsoft Engineering and Confluent Engineering worked a number of years to bring together, and we're really proud of it. And so if at any point you're curious about what we're doing or how to do anything Confluent, just pop over to Azure Marketplace, find Confluent Cloud, and hit the Try It Now button. It's free to try. $200 a month, free for 3 months. $200 each month, free for 3 months. And we're really proud of the integrations that you'll see that Confluent and Microsoft have driven together. So with that said, I do have a question for you, Dan, to start with. This is from Barry. I don't know if you can see it in the Q&A screen up top, but if not, he has a question on determining the best way to isolate topics so that his dev teams can iterate without having to get bogged down in contract negotiations on messages with a bunch of consumers. If all topics are private in a single dev team, such as the one team owns for all producers and consumers, that would maximize productivity but limit the reach of the information. And so I don't know if you can see the question. It goes on for a little bit more, but you want to start with the top of that, or?
Yeah, actually my Q&A panel isn't loading right now. It just keeps spinning. But how you kind of segment data on a topic for Kafka, there's a lot of ways to do that. You could do it by partition keys. You could do it by separate topics with each with their own set of partitions. And one thing to keep in mind is if you are going to put multiple consumers or multiple sets of data on a single topic and maybe isolate by like partition key, you really have kind of a multi-tenant architecture from that. So that may not necessarily be what you want. It might be the behavior of another actor on the topic can start to use up capacity that is the limit of like a partition, basically is the unit of work in a stream. So it's also possible that you might want to have all your data come in through one topic and then make subsets of it that go into other topics using something like KSQLDB or some sort of stream processor of your own. And then you can kind of fan out that way. And then you can filter out what subset of data goes to each consumer, and you can separate the consumers from each other so that you can scale better. Because they'll be on separate partitions then, and those partitions can live on separate hosts, and you'll kind of get better behavior out of that. I think that might answer some of that, but is there a follow-up or more detail? I'll dive in further.
There was, but and we've got his contact information, so we're gonna we'll reach out, or Barry, please feel free to add more. I do want to kind of direct the next kind of topic over to Alicia. Database migration and data in motion. Can you talk through the connections Confluent has to key Microsoft services in cloud like Cosmos and the rest, and why those matter?
Yeah, I'd be happy to, and thank you for having me. And just to give everyone a bit of a background to what I traditionally do, I'm a traditional DBA. So I'm used to people coming over and asking me, well, how do I get my data from here to here? And what is the best way for me to maintain the data integrity and make sure that my data is safe and my systems can run with minimal downtime. So when we're looking at moving data from different places, and with everybody looking to the cloud as a way to leverage these new technologies, Kafka definitely is a tool set that people can benefit from because it lets you expedite the process in a very safe way, a safe known way, given the amount of Kafka usage in the market. And we can look at this architectural diagram, and you can see that with on-prem systems, there are a lot of integrations already in place with the Confluent platform. So when people are looking at moving their data from on-prem to the cloud, it's an additional hop versus an additional ETL project. And coming from a traditional data engineering, data warehousing type of environment, this was really a new concept to me. And just thinking about the different ways that you can leverage the system to kind of scale out and also jumpstart these additional projects that are dependent on this data on-prem, that was really eye-opening to me. So we can see that we've got Confluent platform on-prem with source connectors to these traditional data warehousing systems or these traditional EDW and mainframe systems, and many of the popular database systems. And we can go ahead and replicate data from Confluent platform to Confluent Cloud. Now, once we get to the cloud, we can leverage fully managed connectors to many of the popular Azure native services. So we've had tremendous success with working hand in hand with the Microsoft development teams. And I've been so fortunate with being able to work directly with Cosmos DB team. We're now working directly with the Synapse team. And the Confluent team has already worked with the ADLS team to optimize the integrations and the connectors that are available for these Azure native services. So, and I'll let Dan talk to that as far as the roadmap for what we see coming up. But we do have over 120 connectors available, and that list just continues to grow and grow.
Dan, so how about that? So one, the connectors obviously incredibly important and interesting, but also what about the native services that we have within Confluent, like KSQL? So how should someone look at, processing you can do with KSQL versus processing you could do in something like a Synapse or a Cosmos?
Yeah, absolutely. The big thing to keep in mind with something like KSQL DB is that it's a stream processor and a streaming database. So it's really made around the idea of data in motion. It is like the transaction log streaming. It's not like the end result of the transaction log, which is really a materialized view. Is you could think about a table as in a database. But that means that you can do things like run real-time queries on it. So you can have a running kind of normal, what people would think of as like a stream processor, but it actually gives you an interactive query capability for that stream processor. So you can say, I have a processor running that's doing an average, a moving average of like the last 10 prices of something, and then publishing that, or bucketing up every 5 minutes the orders by country. And it's cool to get that, but usually the stream processor then has to go dump that state into somewhere else to be queried. But you can actually interactively query this. But it's really meant to be a live point in time thing, not like a historical record. Although you could start a query up on or a job on a previous state, rewinding in the Kafka stream. So it's meant to do some things, not everything, and it's certainly not meant to be like a long-term destination of data like you would think of with like a data warehouse. So there are some things that lend themselves better to real time, like that moving average type stuff, like or batched 5-minute windows of sales, like what's the latest 5-minute window. But if you want to see what were all of the 5-minute windows for the last month or year, that'd be more appropriate to do downstream into like a data warehouse. I mean, just because it's not, you know, that's not like a time sensitive sort of thing. If you need to know what's the state right now, that's usually pretty time sensitive. Whereas if you want to know what were changes in segments of state over a long history, that's kind of more of a batch sort of job. So you'd probably push that down to your data warehouse layer.
Makes a lot of sense. And as we start kind of our next topic, which is app modernization, and I would invite anyone to pop on and ask questions if you'd like. We are watching the question stream as we go. But on the app modernization front, I guess one of the first questions I'd ask Dan, and then I'll turn the next slide over to Alicia. Sometimes people refer to Confluent as near real time, and others will say real time. I know you have an opinion on this. So from an app perspective, is this real time data, or what's the difference?
Yeah, so I would say as far as the cloud is concerned, it's real time. When people tend to say the concept of real time and mean like something different from it, the only place people tend to do that is in control systems. Think about things like the joystick on an airplane. You know, the joystick on an airplane needs to have very predictable response times, response characteristics, so the pilot flying it gets the same behavior. So it's not so much about being fast in a hard real-time system, which again, this is like super low level. General purpose operating systems don't get into this area. RTOS does, real-time OSs. It's about those types of OSs are about predictability, not about speed. And so unless you're working in the RTOS space, which very few of us do, this is real time. You know, and near real time tends to be something like more like micro batching, or maybe minutes or seconds, whereas like real time tends to be, you know, sub-seconds, milliseconds, and low latency, which is not like the RTOS stuff is not necessarily about low latency. Like I said, it's about predictable latency.
Excellent. Alicia, when we look at, you know, Azure app modernization, what are some of the use cases, and what are some of the apps that you see most common when you're working with customers in the Azure space?
We often see a need for, you know, both hot and cold streams of data with modern applications, and you know, usually we see multiple data stores for these events. So whether you're writing one stream to blob storage and writing another stream to a database, when we're building these modernized applications, it's really creating the ability to trigger on real-time events, but also providing the ability to collect and store that data and provide analytics so that we can also leverage AI capabilities. And I do have to throw that in because AI is one of the favorite topics of mine. So, you know, it's really twofold. It's creating that ability to respond, and also creating that ability to respond more intelligently. And you're probably going to ask different questions of different sets of data, and that data is probably going to be stored in different types of storage. So what you're looking at is the need to have the ability to work with multiple types of storage that's housed in multiple different systems. So when we look at building out, and then you need to do this quickly, right? So when you're building out new Azure native applications, and most of the time we do this in a hub and spoke model, we've got multiple teams working under one tenant in Azure, where we want to give them enough control to build quickly, but we also need some type of control system on place. So Azure is like a great environment for people to get up and running and kickstarted. And we do see a lot of customers using Kafka to jumpstart that process, because we don't have to move the data and then build the application. What we can do is we can go ahead and push the data through, and we can have a second set of live active data where developers can do true development off of. And it's the devil's really in the details when it comes to the data, right? Like it doesn't matter how much time you put into your test data if you're generating that by hand. You really need true data sometimes to kind of work out all these bugs for these applications. So being able to replicate those full data sets and really kickstart that prod, non-prod development data sets really helps expedite that Azure native build. And also you can use a whole bunch of APIs to reference Kafka. So not only can you use Azure Functions and Logic Apps, but if you're doing the analytics, you can also embed those queries into languages like Azure Databricks and Azure Synapse. So Kafka is just really convenient for a wide range of developers.
Love it. Dan, I love just saying this term, so I'm going to throw it in there, but I think it's also an important term to say. What is Kafka stream enrichment? When we say we're going to enrich a stream, what is that, and why does a developer care?
Yeah, that's a deep rabbit hole. So you could think about a lot of things in the world just speak Kafka already. Like there's a log for JAppender or log for NetAppender for Kafka. So lots of applications just output to Kafka, but they're going to output in the language that's useful to them or the format that's useful to them, which may not be the format that's useful to you or downstream applications. So for instance, if they have say the message has like a primary key within it, coming out of some application, unless you know like unless that primary key has significance to you, or foreign key, I guess, to be an even better one. Like if a record just says some number that's a foreign key to some lookup table, it might be real hard to do anything useful with that data. So one type of enrichment that's really common is to go do a join to another stream or to a static set of data about what those foreign keys might be, or what the key value pairs might be, or even how you might go call other APIs to add to the messages, to the stream, I should say, to the messages within the sequence that is the stream, so that information, that the individual messages in the sequence, become more useful later on to someone else. And that type of enrichment is it's pretty typical, unless you live in a real homogeneous environment, which is like, I don't know, Azure alone has hundreds of services. So it's just not the case that people live in a homogeneous environment. Data tends to be pretty heterogeneous. So that enrichment can happen through a variety of ways. You could do it with Azure Functions. You could do it with KSQL DB. You could do it with connectors that do SMTs, to single message transforms, to go change the message as it flows. So those are all different types of enrichment. And it kind of depends on what you're trying to accomplish, of which one you might need. And then there's earlier when I mentioned the temporal stuff, then there's one is just enriching a message. The other is creating a completely new derivative set of data off of that stream, which might be windowed or joined in a different way. So those are kind of the two big categories that I see a lot.
Love it. One of my favorite new connectors of ours and new stream conversations of ours is obviously our ability to reach into Oracle. Alicia, you want to talk through what we announced and what that CDC connector can do?
Yeah, so we recently announced the Oracle Change Data Capture connector. And this is really going back to our conversation of, real-time and near-time data capture and providing the ability to respond more quickly to events. So this connector actually opens up a whole bunch of applications where we're able to modernize some of these more legacy systems that are out in the wild, where previously there weren't as many capabilities for integrating directly with the systems.
And Dan, one thing that's showing up on all of our slides, and I'm not sure we did a great job of explaining it to people. What's Replicator, and why is it cool?
Yeah, so this is kind of important to the evolution that's happened with streaming and data in motion that's going on right now. Is Replicator is a way to replicate data in a topic or set of topics from one cluster to another. In the beginning of Kafka, there was just like a Kafka cluster that was the center of your universe. But that's like the old days when there was a database that was the center of your universe. And that's not really the way the world works increasingly. Is instead of being like a center, there's lots of centers, and they're connected together in some sort of way, or you want them to be. And Replicator is the way you can do that with like a controlled mechanism to say, I want some of the topics from this cluster replicated into some other region or some other, maybe from on-prem into the cloud. And then you can go do processing with them in the cloud. And you might make like a hub and spoke diagram of clusters that are all on-prem, maybe in factories or something, but replicate sets of their data, possibly subsets, into a centralized cloud place to do analytics on or do other operations on. And that's pretty common now. Like that's the kind of the evolving world here, is this moving away from like a hub. People would think hub and spoke and like think the hub is the center and that's the center of the world. But if you look at like the way FedEx designed the hub and spoke model, it's that there are hubs all over the place with spokes kind of to the last mile, and those hubs are connected to each other. And so what you really get is like a graph or a network, and Replicator really helps you connect the network and understand the flow of what's going on in the network.
Excellent. And so as we start seeing it all together and putting together in a whole Azure data and AI point of view, one question that we didn't get that I would definitely like to see us address here is, how do we handle disaster recovery, Dan? So if someone signs up for Confluent Cloud, I hear there's some Azure AKS in there, and I hear there's some availability zones, but what does that mean to the customer? Oh, sorry, I think you're muted.
No.
There we go.
Not can you hear me? Okay. So one thing to keep in mind is like the difference between HA and DR is that everything in Confluent Cloud is already HA. We actually use regions that have availability zones so that we are not stuck in a single zone, and we have availability higher than just a single zone. But you might have situations where you want to have like cross-region DR capabilities. And that's actually one of the things people use Replicator for. And we actually have something called cluster linking, which serves that purpose as well, but is built into the cloud product and built into the protocol of Apache Kafka and how it does replication at the broker level between partitions. So doing DR today is more of a decision about what sort of DR do you want, like what sort of RTO and RPO you want. And we have a variety of ways we can help you meet that. Obviously, people will say, I want RPO 0 and RTO 0, which basically means like a geo stretched cluster. Those things are difficult and expensive and slow just because of the nature of physics, depending on how far your nodes are apart. And most people end up with something where they have a defined and acceptable RPO and RTO. RTO meaning the recovery time objective. How long does it take me to get back and running again? And RPO meaning recovery point objective. How much data am I willing to lose? And if you're in the, above seconds realm or maybe minutes for those, then Confluent Cloud certainly can meet your needs already. And most people live in that place. And a lot of enterprises, just having like hours or even days to get back up and running is considered good enough, because these are not like a disaster recovery is not meant to be like it's a Tuesday and I feel like changing where the traffic's going. It's a disaster. It's like earthquake, fire, big fire like the kind we get out here in California, and not, I mean, they're not moves you take lightly. So we kind of encourage people, and I did this back when I was in Azure as well, to use like a fail forward model, so that California falls off into the ocean and you move from US West to East, and then you set up a new region as your fail over maybe South Central and move forward, fail forward from there.
Excellent. We have 4 minutes left, and so I think the logical next step is, if someone is interested in getting started, where can they learn more? And so, Alicia, I hope you don't mind me putting you on the spot, but can you talk a little bit about your YouTube series you've got going on learning Kafka on Azure, and where to get started?
Thanks, Coop. Yes, so I do have a Azure specific learning series on YouTube, and the channel is called Kafka and Azure. If you are not the type to read through the instruction manual when you set up your electronics, then this is a perfect medium for you to learn. It's a series of 5-minute sessions, and I prepare a lot of documentation and go over things very high level and specifically, so that you can absolutely get kickstarted on your journey. I firmly believe that Kafka is a tool that every data professional should be at least aware of, and moving forward, probably in the very near future, have some level of proficiency. And this is only going to provide you additional value as you're able to enhance your skill set and build these kind of modern and forward-looking applications. And especially at the architectural level, if you're aware of the capabilities, then when you're having these discussions about whether to use A or B, or how do we do this faster, or how do we make this easier for our customers' journey, then it's, those are the types of answers that I try to actually speak to during the session, so that you're able to participate in the conversation. So definitely excited at the opportunity to work on the product, and working with the Microsoft team. Microsoft Docs does have quite a few different tidbits about Confluent, and they do reference the Confluent site. We have excellent documentation available on the Confluent site. There's tons of code out there on GitHub. We do have a GitHub repo that's specifically for Azure examples. And we'll be going over some of that code in our table talk session tomorrow. So definitely stop in and see our session with Ramya Organti and Israel Ekpo. And we'll be going through a little bit of GitHub code. But the Kafka community is this huge community of people who, just like the Microsoft community, are just so open and willing to share information about how they've solved these technical challenges. So as a Microsoft professional, there's tons of information out there to help you get started.
Thank you. I want thank you, Dan. Thank you, Alicia. This has been very informative for me. Granted, I got to cheat and ask all my favorite questions, but I learn every time I listen to you guys talk. So thank you guys, and thank you to our friends at Microsoft for hosting us.
Thank you.
Thank you.